Hello viewer, dear candidates for Kcse 2024 and beyond, until the time we shall be done with 844 system Kenya. Welcome back to our lessons. Remember, we changed our name from Wilfred Momanyi Onkangi-Kiongozi to Smart Learners Studio-Kiongozi, that is SLS. Welcome back to our studies. We have a question here today and we want to discuss on what we shall do when we are solving trigonometric equations. This is a chapter in Form 4 and please make sure you have somewhere to write. There is a quadrant that is a very nice tool that is used in solving trigonometric equations, and today I want us to discuss about the quadrant, then at least do one example using that quadrant, and then we move on together like that. Thank you very much for your time, and please make sure you concentrate in this lesson. So a quadrant is a tool that we use in solving trigonometric equations, and as you can see, I have labeled it ASTC, commonly known as all students take chai, chapati, or any food that is good, that is that begins with C. So now in the first part we have theta. You see this is 90 degrees, 90, 90, 90 to make it 360. We have theta in this first part. The second part here, all angles in this S are going to be less than 180, so we say 180 minus theta. Remember, at this point this is 0, at this point is 90, then after another 90 we have 180, then after 90 we have 270, and then finishing the quadrant or one round we get 360. That means all the four parts of this quadrant. So when we are listing the angles, we are likely going to get a kind of a mechanism or a formula whereby we begin with theta. The first angle is theta and is in the first quadrant. The first angle in this second one here is 180 minus theta, followed by 180 plus theta in T, and then of course the last one is all angles in here must be less than 360, so we say 360 minus theta. Remember this, that here with A stands for all, then S stands for sine, and T stands for tan, then of course C for cosine. All these three are what we call trigonometric functions. Now we go the second round. After going around the first cycle of the tangent, we reached where we have the angle 360 minus theta, which is in this last quadrant. We repeat again, but now following the second round, where the first angle in this quadrant for the second time shall be 360 minus plus theta degrees. Of course, from minus we go to plus. Then from there up to this end you add 180. That means this 90 and another 90, so we shall have 540. You can see that minus theta, followed by 540 plus theta. Then from this point all the way to this last end here, you add 180 to 540, you will get 720 minus theta. That means you have gone through the quadrant circle twice to make it 720. That is 360 times 2, 720 minus theta. We go round 3. Round 3 we begin with this angle that we finished with here. We shall have round 3 we have 720 plus theta, of course degrees. Then you add 180 to it, you will get 900 minus theta. We follow it by 900 plus theta, and finally as we go down to this end we shall have, you add 180 here, we have 1080 minus theta. We go for another round. We begin with this one, so this one is a very good turning point. We have 1080 plus theta. Again you add 180 to it, to this side you will get 1260 minus theta. Then of course 1260 again here, 1260 plus theta, but now you add 180 to it, you'll be at I think 1440 minus theta. If you're interested to go the next round, another round, you will begin with 1440 plus theta. You go around like that until you reach here. You can go as many times as possible, but according to your level and according to the level that a learner in Form 4 Kcse is required to have, you're supposed to just know a few so that you don't go outside the range. So we have said you can go round as many times as possible. Now let us see how we can use this quadrant to solve for a given problem. And I'll write up a question for you. Question for you. Solve for theta. This is an example. This is an example of using a quadrant. Solve for theta in the trigonometric equation below. You can put a colon. Cos 2 over 3 theta is equals to negative 0.7660 for 0 degrees is less than or equal to theta, which is less than or equal to 360 degrees. You are being told solve for the value of theta where cos 2 over 3 of theta is negative. I will tell you the meaning of this negative. And for this range, this one is a range. So the angles you get must all be between 0 and 360. So the first thing is you have to go a few steps. Try to remain with theta. Solution. Ensure you remain with theta. How? Cos 2 over 3 theta is equals to negative 0.7660. You first of all do cos inverse on both sides. If you do cos inverse of this one cancels with cos. If you do cos inverse of this, of course you must use a calculator or what we call a table. So you say, and assume the negative first. So we have cos inverse. First of all, we write this one in the calculator. 0.760 on 0.7660. That is the value we have, and we want shift cos or cos inverse of it, which is 40.00. We can round it off to 1 decimal place, and we shall have 2 over 3 theta is equals to, let us assume the negative first, 40.00 degrees. There is one thing I want you to understand. This negative here only shows you where or which parts of the quadrant you shall be getting your answers from. Because you know, the quadrant has got 4 parts, and in our question, cos is negative. Cos is negative. So, I take you back to the quadrant. In this A or all the cosine, tangent, and sine are positives. In this case, sine is positive, but tangent and cosine are negative. In this case, tan is positive, sine and cosine are negative, and in this case, cos is the only one that is positive, and these two are negative. So, look at our problem. We want where cos is negative. That is now what we are looking for. So, we shall decide which parts are we using where cos is negative. And cos is negative where? Cos is negative in sine. We shall use this one. And of course in tangent. So we shall apply these ones, but still remain within the range of the values that we are looking for, from 0 to 360. So this 40, so 2 over 3 theta is equals to 40 degrees. We are assuming that this is in the first angle. So we pick this one, that is 180 minus 180 minus 40. We put a comma. We are listing the angles before we solve them. Then from there, we go down to 180 plus theta. 180 degrees plus 40, because we are saying our theta is 40. I will show you how we shall simplify them. Continue listing if there is need, but I don't think there is need. I don't think there is need to do any. Let us do just one, maybe this one, because the other one seems to be very big. 540, comma. The last one, 540 minus 40 degrees. Probably we stop there because I'm guessing our range is limiting us. So 2 over 3 theta, if you can see that, is equivalent to, the first angle is 40 degrees, comma, 180 minus 40 is 140 degrees, comma, 180 plus 40, 180 plus 40 is 220 degrees, comma 540 minus 40 is 500 degrees. I'm trying to predict that we are almost outside the range. So what you do to remain with theta, you multiply by 3/2 across, times 3/2 here, times 3/2 here, times 3/2, times 3/2. So we shall have theta is equals to 40 times 3/2. 40 times 3/2. You get 60 degrees. 60 degrees, comma. But remember this first angle. The first angle is in this quadrant of all. So we shall determine whether it is part or not. Then 140 times 3/2. 3/2. We get 210. 210 degrees, comma. 220 times 3/2. We get 330. 330, comma. 500 times 3/2, we get 750. Now from these angles, all of them are solutions, but which angles do we need? We need angles that, number one, are in the right quadrant. The right quadrant, the theta is not part, because theta is in the first quadrant of all, and we are looking for these ones here. Second factor to consider, which ones are within the range? The range is from 0 degrees all the way to 360 degrees. So again, we disqualify 750. Why? It is more than what the range requires us to do. So this one gives us two angles. So the solutions of theta are going to be 210 degrees and 330 degrees. What happens in case you write angles that are not in the range? You lose a mark. If you write angles and leave one angle maybe by mistake, you lose 1 mark. So it's good to be accurate. And for that matter, I will give you the second example. So let us write the second example, but we shall continue using the same quadrants. Second example. So in example 2, this one is like a super example. Write with me the super example. Example 2. I'm calling it super because I know it will bring in some concept that you have not learned before. So we have 2. So of course it's solve the following trigonometric equation. Solve for this trigonometric, or solve for, I think, x. So we have 2 sine bracket x plus 30 close the bracket degrees is equals to negative 0.7986. You must always be given the range. Values of x less than more than 0, greater than or equal to 0 degrees, less than or equal to 360 degrees. We are also given the range. So the first thing is to come up with a small quadrant. Or before we do that, we try and remain with x. So solution, let us do the quadrant, the last one. So what we shall do here, we will first of all 2 sine x plus 30 degrees is equals to negative 0. We can assume the negative first because already the negative shows us where we will locate our angle. So it has no work. 0.7986. So the first thing you do, what can be done, you divide by 2 across on both sides. Why? You want to remain with sine x plus 30 is equals to 0.7986 divided by 2. You get 0.39 3993. The negative sign that I'm assuming here, its work will come later. At least it will show us where we will get these angles. The second thing is sine inverse. Sine inverse on both ends. So sine inverse will cancel with this, but this all you have to calculate either using a calculator. So we have our answer as 0.3993 shift sine. So what we get? 23.53 to 2 decimal places. So x plus 30 is equals to 23.53. 3 degrees. At this point, you will assume that this is the first angle before you solve it. Put a comma. You bring in your quadrant again. We want where sine is negative. Sine is negative. So where do we have sine as negative? Down here at tan and at cosine. So if the angle is theta, we can forget about it a little, but concentrate on these ones, like 180 plus. The first one, 180 plus theta. Now theta is this, 180 plus 23.53, 23.53. You get 203. Now we are listing the values before we simplify them, comma. After that one, we go to 360 minus theta. We take the first, we take the first turn, we take the first ones, and then we go to the second ones that way. 360 minus 23.53, we get 336.47. We continue listing the angles until we feel like we are almost off. Yeah, this one show, I think we are almost done with it. 540, the last one, 540. Let us go to this last one. This one looks like it's beyond 540. 540 plus 23.53, we shall have 563.53. So let us reach there, because I think these ones are beyond, they are bigger. So if we want the values of x, we shall say 30 shall be subtracted from each and every value, because it's a positive here, going to the other side it will be a minus. So 23.53 minus 30, that's the first angle. 23.53 minus 30, that gives you negative 6.47 degrees. Put a comma. 203.53 minus 30, you get 173.53, comma, degrees. 336.47 minus 30, you get 306.47. Make good use of your calculator, degrees. Then the last one, 563.53 minus 30 gives you 533.53 degrees. Now look at this. The first angle is theta. Is it in the quadrant that we want? No. These are the two parts of the quadrants that we were looking for. But if it is here, then we cancel it. We remove it from among the solutions. So we remove this part. The remaining ones, now we look at the range. Both of the three of them are in the right quadrant section. But now, look at the range from 0 degrees all the way to 360 degrees. Which angles? This one is okay. This one is okay, but this one is not. I also cancel this one because of being bigger than the range. So the solutions to x are going to be 173.53 degrees and 306.47 degrees. My learner, I want you to understand how to use a quadrant. And for that case, make sure you know how these values are put, and when you are choosing whichever part of the quadrant that you shall be using. Thank you very much for your time. See you in the next video.